Chapter 6 of David Albert's book is called The Asymmetries of Knowledge and Intervention. So now we are going to focus on two things that are really specific to human beings. Right? We know the world and we intervene in the world. We do things, we change things. And both of those seem to be asymmetrical between the past and the future. We know different things, certainly, maybe more things about the past than about the future. And it seems that we can intervene towards the future, but not towards the past. Right? Nothing that I'm going to do is going to make a difference to the past. That's just not going to happen. And so we would like to understand them. And of course, being a chapter in this particular book, the story is going to be a story that delves deeply into, and in fact uses a lot of, the philosophy of physics that we developed in the first 5 chapters. Now, in preparation of this video, I asked some questions of David Albert, and we ended up having a Zoom meeting. He is an extremely nice guy. He was willing to take a lot of time to answer my questions and discuss how he now thinks about these issues. And one of the things that Albert told me is that for him, when he wrote the book, chapter 6 was sort of the thing that the entire book led up to, right? That was sort of the high point. And then it turned out that reviewers and discussions about it, they all focused on especially chapter 1. Nobody talked about chapter 6. And so that was maybe in some sense a bit of a disappointment. But we're going to talk about chapter 6, right? We're going to talk about it right now. So let's think about knowledge first, as the chapter does as well. What can we say about our knowledge of the past versus the future? One thing we could try to say is that we know more about the past. Certainly, this would be, I think, more precise. There are many kinds of things that we know about the past, often with very high accuracy and certainty, that we don't know at all about the future. Definitely not with anything approaching certainty or even probability. So it is very easy to look up who won, like basically every professional football match played in 1986. And you can't look up who's going to win those matches in 2052 or even next year, right? We just don't know that. Here's a more sort of anthropic example, maybe. It's very easy to know what shape the egg splattered in that you dropped a minute ago. Like maybe it was a shape that really looked like, I don't know, Gondwana land. It's impossible to know what shape the egg will splatter in that you're going to drop 1 minute from now. Right? No idea. So there seem to be lots of kinds of things that we can know about the past but not about the future. And now we would like to know why. How does that happen? And the way that Albert is going to approach this is he's not going to tell some kind of metaphysical story. He is going to think about our methods, the methods that we use for gaining beliefs about things, the methods that we use to reason about the world. And one could think that the only method that we have is the following. Right? We observe the world around us, and so what we have in the most ideal case, which we're never even going to be able to approach, but in the most ideal case, we're going to have a description of the current macro state of the world. Now, a description of the current macro state of the world, when we want to apply the laws of nature to that, is not going to tell us much. Right? If you have a gas in a container, having only the macro state, you just don't know whether the gas in that container is gonna sort of congregate in one corner in the next minute or whether it's gonna stay distributed. That depends on the micro state. Right? So we need to, before we can even try to apply the laws of nature to the state of the universe, we gotta say something about its micro state. Now we don't know the micro state, but maybe this is what we do. Maybe we say every microstate that is compatible with the current macro state of the universe is equally likely. Like all the microstates that the universe could be in the sense of that fit the current macro state, are equally likely. Now that's not really going to work because there's presumably infinitely many of those microstates, and so they're all equally likely because they all have probability 0. So we're gonna have to do some sort of mathematical stuff with volumes in phase space and so on. But that is in principle possible, let's say. Right? So we are going to adopt something that we can call a principle of indifference. Right? We only know the macro state. So let's say that all the microstates are equally probable. And then we apply the laws of nature. Right? And if we apply the laws of nature and we do it towards the future, what are we going to be able to predict? Well, one thing that we're going to be able to predict is, of course, that the future will have a higher entropy than the present. That is very likely. It's overwhelmingly likely. Another thing that we will be able to predict is that this half an ice cube in a glass of lukewarm water is going to melt. I mean, that's something we're going to be able to predict with very, very high probability. Presumably, theoretically, we will also be able to predict all the kinds of things that we usually do predict about the future. So Albert, for instance, he gives the example of predicting that Henry is going to love the movie Lost Highway. Now, clearly, there's nobody in the world who actually knows how to use any talk about microstates and the laws of nature to predict what somebody will think of a certain movie. But at least there's nothing incompatible with, on the one hand, the idea that we use these kinds of predictions, and on the other hand, the claim that we might be able to predict something like that. Right? If you know Henry's macro state, maybe it turns out to be very likely that after seeing Lost Highway, like you know the macro state in this particular case, the way that his brain is wired and so on, it might be very likely that he says, wow, that was a really great movie, and very unlikely that he says, oh, I hated that. So maybe something like that is possible, even though that's not how we would do it in practice. So that's the future. What about the past? Right? Using the same method of having the macro state, the present macro state of the universe, having this sort of uniform probability distribution over all the microstates, and then just applying the laws of nature. Well, having read chapters 1 to 5, we can answer this question. Right? It is extremely likely that in the past there was very high entropy, not low entropy, high entropy. It is very likely that this half melted ice cube in a glass of lukewarm water, like 10 minutes ago, was just a glass of slightly colder water where an ice cube has suddenly appeared in it. That's a lot more likely than there having been a full ice cube, and so on and so forth. Right? We might be able to predict some of the things like that look like Henry is going to love Lost Highway, but we're definitely not going to be able to predict any of the things that require high precision knowledge of microstates, like, oh, what is going to be the shape of an egg that has splattered on the ground or anything like that. We don't have that kind of knowledge. We don't have that kind of predictive ability, even when we're going to go back into the past. And so what we are able to do using merely this method is going to fall extremely far short of what we take ourselves to know about the past. Because we take ourselves to know a lot about the past based, of course, on all kinds of records. Right? Those sports games that I mentioned, we have records of them. Maybe you made a photograph of how this egg splattered into the form of Gondwana land, and so on and so forth. So there are lots of records of the past that we believe give us knowledge about that past. But using only the method of taking the macro state, a uniform probability distribution, and applying the laws of nature, what we would have to conclude is that those records are most likely all false. Right? They do not actually reflect anything that happened in the past, because the entire universe as we see it right now happens to be a fluctuation from high entropy, and that's going to go back into a high entropy soon. So that's what we would have to say. And if that's what we would have to say, then we end up in full-blown skepticism. Because if all our records of the past are probably wrong, well, including the things that are probably wrong, is all our evidence for Newtonian mechanics or thermodynamics and so on and so forth. All that evidence, like those experiments, were probably never done. So it's completely, we have no idea whether any of it is true. And that means that we don't even know whether the kinds of predictions and retrodictions that we can make have any probability of being correct, and so we end up knowing nothing, right? And that would be a disaster, right? That would be a massive disaster. So, faced with this kind of skepticism, which is basically the same as the Boltzmann brain skepticism that I mentioned in earlier video, where, what we might think that all our current memories and ideas and so on are merely happening to a little brain that fluctuated out of high entropy chaos and will soon return to high entropy chaos. And this entire world that we see around us is merely a figment of the imagination. And looking just at statistical mechanics and assuming that all microstates are equally probable, that would seem to be much more likely than the real existence of this world. Like, with that kind of skepticism, you've got to either completely ignore it or try to face it head on. So how can we face it head on? Well, we probably do not want to give up the idea that the current macro state of the universe is the current macro state of the universe. I mean, that's true, and that seems to be very important if we want to predict or find out about the past, anything, right? We also, we don't want to give up the laws of nature that we have found. We want to keep those. But we used a third ingredient in our reasoning just now, right? And the third ingredient was this principle of indifference, or this idea that the probability of every microstate is equally great. And that is something that we might be able to give up. In fact, come to think of it, it might not be so clear why we ought to believe that. Why ought we believe that every microstate is equally probable? Well, here's one kind of argument that people might give, that people do give. They say, well, whenever you don't know something, right, then all the things that you don't know should be treated the same way. Like, all the possibilities of which you don't know which is the right one should be treated the same way. And so they should be given the same probability. Right? Suppose that you walk into a room and there's a red box and a blue box, and you're told one of them contains a ball. What's the probability that it is in the red box? According to this kind of reasoning, what you have to say is 50%. Right? And because you don't know where the ball is, could be in the red box, could be in the blue box, so it's 50-50. Right? It's 50-50. Now, one thing that happens with this kind of principle of indifference is that it quickly leads to paradoxes. Right? Suppose that there is an election and there are three candidates. It's John, it's Mary, and it's Linda. John, Mary, and Linda. You could say, oh, well, you don't know which candidate is going to win. Like, I know nothing about it, right? I know nothing about the election. I don't know which candidate is going to win. So John, Mary, and Linda all have a 1 in 3 chance of being elected. But of course, I could also say, well, I don't know whether a man or a woman is going to win, so it's 50-50, right? 50% man, 50% woman. And then you have very different probabilities, because now suddenly John has a 50% chance because he's the only man who could be elected in the election. Okay, so let's return to the boxes, right? I mean, suppose that we don't care about that kind of paradox, although I think we should care about that kind of paradox. Still, should we say that there's a 50% chance that the ball is in the red box? I would say no. Maybe there's a guy who puts the ball in one of these boxes every day and he loves red and he puts it in the red box all the time, and that means there's a 100% probability that it's in the red box. I don't know about that. I don't know what that probability is because I don't know about this guy and his love of red boxes, but that might be the right answer, right? The right answer might be that there's a 100% probability that the ball is in the red box. It seems to me that my epistemic state is not, it seems to me first that the state of the world is not best described by saying that there's a 50-50 chance of the red and the blue box. I mean, the state of the world might be best described by saying that the ball is always, every single time, in the red box. I mean, that's possible. But it also seems that my epistemic state is not best described as saying, oh, it's 50-50. Because there are a couple of very different epistemic states here, right? Suppose that I know that the ball is always randomly put into a box, right? Maybe even using quantum randomness or something like that. Then there's a sense in which I might want to say that there's a 50-50 probability, and that I know that there's a 50-50 probability. That's something I might want to claim. But suppose that I know nothing. I have no idea how this ball is being put into a box. I think I should just say that, right? I don't know. It's either in this box or in that box. That's all I know. There's really no sort of intrinsic reason or very obvious argument why I should apply 50-50 probabilities. Okay, so let's think back to the current macro state of the universe. Should we assume that the probability of the universe being in any microstate compatible with the current macro state is equally likely? Well, given that we think we know lots of things about the past, which have implications for the current microstate, the answer would seem to be obviously no. Right? If we take ourselves to actually know something about the past, then this principle of indifference is clearly wrong, because we don't live in just any microstate. We live in one of those very special microstates that come from low entropy, that come from a low entropy past. And so what we think we know about the past and this principle of indifference just clash. You can't believe both of them. And why would we privilege the principle of indifference, or this particular version of the principle of indifference, over what we know about the past? Right? It might seem to make perfect sense to actually take all those records seriously and say, well, we know that that's the case, and so the current state of the universe, like the current microstate of the universe, is not just any microstate compatible with the current macrostate, is one of a very special select few, namely those that come from this past that we have all these records of. Alright, so what Albert is going to tell us is that in order to reason about the world, first of all, we do it differently when it comes to the future and to the past, you could say. But that is because we don't do it using the method that we just described, right? The earliest method that I described, where you have the macro state, the principle of indifference, and the laws of nature. That's not how we reason. In fact, what we do is we indeed trust all those records. And now Albert is going to make an important point about records. He tells us this. He says, look, if you take a measurement device gives you information only given that you know two things, right? You've got to know its current state, right, the end state of the measurement, and you've also got to know its beginning state, its start state, its ready state, so to speak, when it was ready for to start measuring. And then something happened in between, right, which got measured, which changed the system from the early state to the late state. And knowing about the early and the late state, you can know what that thing in the middle was, or you can get information about that thing in the middle. That might sound abstract, so let me give an example. Suppose you come to the beach, and in the sand on the beach you see one footprint. If the ready state of the early state of the beach was just flat sand, and now the late stage is I see a footprint, what do we know? Well, something happened in between that left this footprint shaped imprint in the sand. Probably somebody stepped there, right? That's not 100% certain, but we've got some information to that effect. But that is only true if the initial state of the sand was, well, there's just flat sand, right? Suppose that the initial state of the sand was there were two footprints. And now when we look and there's one footprint, then we've also measured something, but what we've measured is not the creation of a footprint, but the erasure of a footprint, which is evidence for a completely different kind of event. So, in order to gather anything from a record, you need to know something about its current state and the state before the recording happened, right? So, let's take an archaeological or historical example, right? I mean, you dig up the ground, you find some stones, like these stone tools that were maybe, could be appropriately used for cutting meat, stuff like that. You've got to know that these stones do not naturally occur in that kind of shape and form, right? You've got to know that the original stones were very different, and now you see this, and so something happened to them, and you basically measured it, and you gain information by seeing those stone tools. All right, so in order to use measurements, in order to use records of the past, we always need to know something about the past before the measurement. And that means, says Albert, that what we really need, if we want to take all the records seriously that we have, let's say, in recorded human history, then we would have to make some assumption about a state of the world before recorded human history. And if we want to take all the records seriously that include, like, the cosmological history of the universe, then we have to make an assumption about the state of the universe before that recorded history. And that is, of course, going to be, given our current cosmological knowledge, like the thing that we must take ourselves to know is that at the initial state of the universe, at the Big Bang, so and so many years ago, the universe was in this particular low entropy state, which looked roughly like X, Y, and Z, whatever cosmology turns out to tell us. In other words, what we need is the past hypothesis, right? In order to need records, we need the past hypothesis. And so the story that we told about thermodynamics and statistical mechanics comes back here to explain the asymmetry of knowledge, right? The past hypothesis allows us to use records, and records allow us to know things about the past that we cannot know about the future, because the future doesn't have that. There's no future hypothesis, there's only a past hypothesis. I think this is a very intriguing story. I also think that in order to make it work, you need to think deep and hard about how the past hypothesis would actually, in practice, maybe reflect our use of records, right? It's not, you've got to tell something like the entire story of science in order to get from this cosmological hypothesis at the beginning of the universe to all these much more specific hypotheses about measurement instruments that you're going to need later on. So I don't think that just the past hypothesis and sort of an abstract idea of the laws of nature as Newtonian mechanics is going to give you everything you want, but at least you're going to put the puzzle pieces in place that allow you to start telling a story that gives you an epistemic asymmetry between the past and the future. So let's look at the final part of the chapter, which is about intervention. And here I think that it is important that for us to understand what's going on in the chapter is that what Albert really wants to do, I think, is he wants to tell a story that is compatible with all the physics that we've seen and all the interpretations of physics that we've seen, and that implies that the events in the world that are under our direct control make more of a difference, make more of a counterfactual difference to future events than to past events. Right? So the asymmetry of intervention is that what I'm doing right now can have an effect on the future, but it seems that it can't have an effect on the past. And so what Albert is going to do is he's going to tell us, well, these and these and these physical events are under our direct control. Now let's see how much counterfactual difference they make towards fact about the past and facts about the future. And if we have the past hypothesis, and if we have all these record systems, these records of the past, and if we take it to be the case that what is directly under our control is something like the movements of our body or something like that, then you can tell a plausible story using something like David Lewis's theory of counterfactuals that shows that the movements of my body right now have a lot more counterfactual difference in the future than they have in the past. So, for instance, take this video, right? My bodily movements in the near future are going to determine whether this video gets uploaded to YouTube and seen by you or not. right? And so there's some counterfactual story to be told that if I move in a slightly different way, so maybe if my brain gets wired in a slightly different way or whatever, then you're never going to see this video, whereas in fact you're watching it right now. So that is under my control right now. But the video I uploaded, let's say last week, which maybe you already saw, even before I'm recording this video, some people already saw it. So there's lots of records. And there's no good story to tell about how my bodily movements right now could sort of counterfactually wipe away, you could say, those records or something like that. There doesn't seem to be the right kind of dependency. There's no physical story to tell how my movements here and those records interact in such a way that if I move a little bit differently now, the records are never going to have existed or something like that. The claim is that just sort of comes out of applying this analysis of counterfactuals to the situation that we have, where in the past we have all those records which we should take into account, and in the future we don't. Okay. And I think that as a story about the asymmetry of intervention, it maybe does what it sets out to do. If what it sets out to do is just show that there is a physical story to tell about counterfactuals linking present events involving my body to events in the past and events in the future. I personally do not think that that would be a full story about the asymmetry of intervention. In particular, I think that, there must be a sense in which it is not just hard to counterfactually influence. It's not just hard to intervene in the past. It's not just that I have less control in the past than in the present. It's that I have no control about the past, whereas I do have control about the future. Right? It's just not the case that by moving my body right now, I can change anything about the past, including, let's say, the exact microstate of my brain or something like that. And you're not going to get that out of this analysis. Or you're not going to get that out of it. And so I think that the conclusion is in probably too weak. And personally, I would like a much stronger metaphysical story where, the past can't be changed because it's, in a sense, real or there, or at least has a different ontological status than the future, which isn't there, which is open, and so on and so forth. Or I have actually sort of defended this in a paper that I wrote in Dutch, so it's not accessible to most of you. Or maybe we should say that what we do right now actually can influence the past or has counterfactual consequences for the past in much the same way as it has for the future. But that's okay, that would be very speculative. Albert, I think, is very he's very happy with a sort of Lewisian, neo-Humean story where we don't try to put a lot of metaphysical emphasis on things like human intervention, or where we don't really sort of try to have a robust asymmetric metaphysics of time. And given that framework, the kind of story that he's telling here in chapter 6 seems to me to make a lot of sense. But it might not give you all the goods that you want if you think that the asymmetry between the intervention asymmetry between past and future is not just a matter of degree, and is not just a matter of, let's say, how we happen to analyze counterfactuals, but is something much more robust and much more fundamental than that. Which is what I happen to think about the nature of time and the nature of human agency and consciousness and so on. Alright, well, that was chapter 6. And in a sense, it is the end of the book. In the sense, namely, that we have now sort of worked through the way that statistical mechanics and thermodynamics have to be understood, what they tell us about the world, and how finally our own relationship towards the world in terms of knowledge and intervention is caught up with that. There is still another chapter in the book, and it's kind of a side road. It's kind of a new thing that gets added, as a more or less promissory project that, hey, maybe we can reimagine everything we just said if instead of just looking at classical physics, we look at quantum mechanics under some of its many interpretations. So that's the next video, chapter 7, about quantum mechanics. Thank you for listening.